All right, this is that number 2 on that worksheet we had the other day. I think what I would do is I would begin by drawing 2 number lines. One for derivative and one for second derivative. For x less than -1, so there's -1. For x less than -1, the first derivative is negative, which means the function is decreasing. And the second derivative is negative, which means the function is concave down. Second derivative negative. Second derivative tells us concave up, concave down. Then it says, between -1 and 2, the derivative continues to be decreasing, but the second derivative changes. It becomes positive, which means the function becomes concave up. So we have that. All right. Between 2 and 8. Between 2 and 8, the first derivative is positive, which means we have increasing. And the second derivative between 2 and 8 is still positive, which means it's still concave up. So that tells me something. What's happening at x equals 2? What's changing? No, it's not an inflection point. At x equals 2, the derivative is going down. Then I get to 2, the derivative is going back up. So 2 has to be a minimum. I do think I have an inflection point already, or a potential inflection point anyway. I have a potential inflection point at -1, because at -1 my concavity switched from concave down to concave up. Why do I say potential inflection point? I don't know the function. I don't really know that I can take -1 and plug it into my original function. So it's possible at -1, I might not actually have an inflection point. I might have something else. Could certainly be an asymptote. Absolutely. Certainly could be. All right, let's keep going. Between 8 and 10, derivative is positive, which means still increasing. But between 8 and 10, second derivative is negative. We go from concave down. That tells me I could have another inflection point at x equals 8. Concavity switched. And finally, bigger than 10, first derivative positive, second derivative positive. Which tells me concave up, which tells me I have another inflection point at 10. Okay. So, here's x equals -1. X equals... You want to be able to see? I didn't really leave myself enough room here. You know what? I'm going to draw it on a separate piece of paper. I need more room. There's -1, and then my other important points are 2, 8, and 10. Okay, so when x is less than -1, the function has to be decreasing and concave down. So what does decreasing and concave down look like? It's going down and it's curving. Of course, you're looking at me backwards from the way my pen is going. But in a picture, it has to be concave down, which means it looks kind of like an upside down parabola. And it's got to be curving that way, right? To be concave down. And then what happens at x equals -1? But it continues to be decreasing, doesn't it? So it's going to continue to go down, but it's going to start to look like a regular old parabola. And it keeps going down and down and down until I get to x equals 2. At x equals 2, I have a minimum. So at x equals 2, the graph starts increasing, but it continues to be concave up. So it's increasing concave up, and it's concave up until I get to 8, and then it has to be concave down. So it's got to curve that way until I get to 10, and then it's got to be concave up again. So I think there's one potential answer. Why do I say potential answer?
Technically, you can move that graph up and down all the way.
I have no x and y value. I have no y values. So that graph could be translated up and down as much as you want. My minimum could be much lower. I don't know. But that's still, other than translating it, that's still not the only correct graph.
Then you can make some of your slants longer, steeper.
Correct. Or, we even said that this sort of thing could happen. At x equals -1, there might actually be a vertical asymptote. So my graph might be decreasing and concave down and look like that for x smaller than -1. And then when x is bigger than -1, it has to be decreasing and concave up, so it might be like this. And then I have my minimum at 2, and then I get my other 2 inflection points. So I think the right-hand side over here kind of has to have the same shape. It's got to be up, and then it's got to switch to concave down, and then switch to concave up. So I think that has to have the same kind of shape. But I think over here on the left, a couple different things could happen. So I think there's another potentially correct graph. So I don't think there's only one correct answer for this problem. Other questions?